So I'm Professor Fernandez. I teach in the math department here. I just actually submitted my tenure application, so if everything goes well, I'll still be here next year. So feel free to send me an email or look me up in the directory, either if I'm here or not, and I'd be happy to talk about this further or anything else that is math related to the college, our courses, our department, our major. So today I wanted to specifically focus on student success in math. And the talk will, as I'll indicate shortly, focus on pretty much what we care about here at Wellesley College, women in math. So how do we get more women interested in math? How do we get them majoring in science more often? And how do we get them into careers that are more science-based? So I'll talk about a few easy ways to boost those successes, informed by the research. Oh, and you might be tempted to take notes or not, depending on your college years. But this talk is online, and at the end I'll give you the link, so you can just download the whole thing. Okay, so this is just a quick note. So I based the talk off of a forthcoming chapter in a volume, edited volume called Constructivism in an Age of Accountability. So I'll get to the meaning of this term, constructivism, later on in the talk. The chapter that I wrote is called How Constructivism Can Boost Women and Minorities' Success in STEM Fields. So it's a little bit of a broader net than what I'll talk about today, but I'll discuss the main points from the chapter. So I'll focus today on women. Much of what I will say holds true for men as well. So here's a quick outline. I'm going to show you a little bit of data, statistics on the gender gap in STEM. This is pretty well known, but I want to back that up with some numbers, and then give you 3 research-based tweaks for boosting success in math, specifically for women. And then this holds true also in other science fields. And then I'll tell you about how we've implemented some of these here at Wellesley through our Wellesley Emerging Scholars Initiative. So first thing I want to talk about is the problem. And what is the problem? Well, there are lots of data indicating that women in general across the nation major in science-heavy fields far less frequently than men. But if you look at the specific fields, they each tell a different story. So all this data comes from National Science Foundation. They publish a report every year, specifically focusing on women, minorities, persons with disabilities in S&E, science and engineering. So this is from 2015, their latest report. So what they show is that 57% of bachelor's degrees in biosciences and social sciences since the late 1990s have gone to women. And this is a nice little chart that they have. So the solid lines here indicate biosciences bachelors and social sciences bachelors. So you can see that, since the early 1990s, it was hovering at about 50%. It's gotten actually a bit more popular. It's leveled off a bit, but more than half of the biosciences and social sciences bachelor's degrees go to women. So, lots of readily apparent questions. Why? Why are those fields so popular? And the trend continues as you go to graduate work. So this first dash is biosciences master's, and then this other dash is biosciences PhD. So even at the master's and PhD level, and look at the PhD, steadily increasing interest to the point where now more than half of biosciences PhDs are being earned by women. And we're almost there for the social sciences PhDs. So women are pretty well represented, in some cases overrepresented in the biosciences and the social sciences at pretty much all degree levels, bachelor's, master's, PhD. So that's one of the things the data shows. So the second thing I want to mention is, okay, well, what about the non-biosciences and social sciences? So here is same data source, the stats for bachelor's degrees earned by underrepresented minority women. So this is now a subclass of all women graduates by field since 1993. So you can see some readily apparent trends. So here's psychology, very popular among minority women for undergraduate degrees. Social sciences, also very popular. So again, we see social sciences pop up. Biological sciences, relatively popular in comparison to these other sciences, which are physical sciences, mathematics, computer sciences, engineering. Those are sort of way low in this graph. Those are fields in which women are specifically underrepresented women, are vastly not majoring in. So if you count the numbers, about 44% of underrepresented minority women who got a science or engineering degree majored in either psychology, social sciences, or biological sciences. So you just add that up. Psychology about 20, social sciences about 14, and biosciences about 10. So that adds up to about 44. So almost half of underrepresented minority women who got a science and engineering degree majored in one of these three fields. That pretty much parallels what was going on in the first graph, right? So there was no distinction here. This is just participation for women undergraduates. There was no distinction for underrepresented women. So it seems to be that the subject matter that's most represented in degree recipients at the undergraduate level and possibly beyond for women is independent of whether they are minority women or not. So this is the first thing that you really can get out of this data. And the second thing is, even though this data only shows it for minority women, it's pretty clear that women in general are underrepresented in specific science and engineering fields, namely mathematics, computer science, engineering, physical science. So the number is single digits in terms of percentages. So low representation in STEM fields. So getting a bit more granular here. So here are, since late 1990s, women have earned only about 20% of bachelor's degrees. So this is zooming out again to women in general, not just underrepresented women. 20% of bachelor's degrees in engineering, computer science, and physics. Here are some of the charts. So the NSF calls these low participation fields for women. So engineering, you can see some of the trends here. So this is increasing in time. So if you start at the bachelor's degree level, the percentage of women earning bachelor's degrees in 1993 was about in engineering was about 18%. And about 20% of bachelor's degrees in engineering went to women in 2002. In 2012, about 20% too. So we're not really making much progress in engineering in terms of getting more women to graduate with a degree, undergraduate degree in engineering. There are more women that are entering the field, so the number of women are going up. But the fact that the percentage is staying constant tells you that the number of men are also going up. And they're going up in some sense equal to the number of women that are entering these fields. So it's a different story. Yes, more women are majoring in engineering at the undergraduate level, but they're not doing it at a faster rate, if that makes sense, than the men. So their representation of the degree percentage is staying constant. And as you get to the master's and doctorate, there is some improvement. That sort of makes sense. If you have more women entering the pipeline at the bachelor's degree level, you do expect more master's and more doctorate students. So you expect that number to go up a little bit more. But still, this representation at the undergraduate degree level is really low. You look at the field for computer sciences, same idea. This has actually gotten worse. So in 1993, it was over 20% of computer science bachelor's degrees went to women. Right now, we're under 20%. This is, totally against what you would expect. In 1993, email was sort of a novelty, right? And today, we're already building robots with some form of artificial intelligence. Yet the representation of women in computer science undergraduate degrees has gone down. So the field has ballooned in terms of interest and applications and relevance. Yet for some reason, at the undergraduate level, that's not reflected in degrees awarded to women. The graduate level sees a little bit of an increase in doctorate and then a mixed bag in master's. So I wanted to show you a couple of more. So here's physics. So same number, about 20%. You're spotting a pattern. Mathematicians like to look at patterns, right? So 20% seems to be a ceiling for whatever reason. Same idea here, a little bit of a mixed bag, but around 20% for physics at whatever level you talk about, master's, PhD, undergraduate. And here's math and statistics. So we are doing a bit better. So I'm proud to be associated with this graph in a very small way as a mathematician and professor at Wellesley. However, same trends. So we have better representation in terms of undergraduate and graduate degrees, but a little bit of a worrying trend. Some of these things you can argue whether they're statistically significant or not, but the data is there. There aren't really that many more women getting degrees in math, and the representation of the overall degrees is shrinking. So this is, all telling about the same story that the first two graphs were telling. For some reason, physical sciences, math, computer sciences, engineering degrees are just not very popular among the degrees that women earn as undergraduates, and even at the graduate level. Social sciences, biostatistics, psychology are very popular, and they're overrepresented in terms of those degrees. So why the stark contrast? What could explain this? So there's been a lot of research done on this. There have been books written about this. So I will try my best in 10 minutes or so to summarize some of the findings. So two important contributors the research has found are the context and the content's delivery. So we're thinking here about, you're in a course, you're taking, Calculus 1. How is the material put in context, or is it? And how is the material delivered? Is it a standard lecture? Do you get to work with students next to you? Do you do projects? So that's sort of a little glimpse into what these two categories are really about. So in more specifics, the content's context. So the American Association of University Women, in their report in 2010 entitled Why So Few Women in STEM, said the following: well-documented gender differences exist in the value that women and men place on doing work that contributes to society, with women more likely than men to prefer work with a clear social purpose. So, this statement in isolation gives you a little bit of a possibility for why psychology, biosciences, social sciences would be popular fields for women, right? So clear social purpose. I teach Calculus 1 every once in a while, and I do my best to discuss the social purpose of calculus, but I will admit it's difficult. It would be a lot easier if I were talking about cognitive skills in a child. That's pretty easy to talk about clear social purpose. So the report continues, regardless of the origin of the difference, most people, so now not just men, also women, not just women, also men, most people do not view STEM occupations as directly benefiting society or individuals. As a result, STEM careers often do not appeal to women or men who value making a societal contribution. This sort of makes sense. You ask somebody off the street, who just random person, what do you think about science and math? And their first instinct is not, they make great societal contributions. It's usually like it's very abstract, it's very tough, it's difficult. More qualities about the difficulty of the work and less about, hey, yes, this is going to help my child, or this will help us solve climate change, or we're going to get clean water to these communities. That doesn't really usually pop up when you mention calculus or, chemistry. So already there's a little bit of a battle, a public relations / imaging marketing battle, if you will, going on. So one of the basic conclusions is that fields with intrinsic or at least discernible societal relevance will have particular appeal to women. So there are the examples: social and biological sciences and psychology. Some of these have intrinsic societal relevance, so psychology. Some of these have discernible societal relevance, like biology. So, a lot of pre-med students end up majoring as undergraduates in biology. So they want to go to medical school, they want to help people, they want to help them improve their health, they want to study different things like how to attack cancer. These have clear social relevance. They have to do with biology. So in their biology course, they may not necessarily talk about this, but there's discernible social relevance in what they're doing. So the first tweak is kind of obvious. So if you want more women in science and engineering fields, like physical sciences, math, computer science, research suggests you should make the content more societally relevant. There are a variety of ways you can do that, but that's the first conclusion. So let's go back to the context. So this is the other half that I mentioned. So this is just as important, and specifically for underrepresented minority students. So in 2010, UCLA's Higher Education Research Institute, they did a survey of 5,000 minority and non-minority STEM majors, found lots of things. So here are one of the quotes from the study. So the relevance of science coursework to students' lives had a significant impact on academic and social adjustment for underrepresented minorities in the sciences. which underscores the importance of experiential learning and understanding the application of knowledge. So relevance assigns coursework to students' lives. It's arguable whether this can be called, clear social purpose. In a sense, it's more like a personal purpose. How does this coursework relate to my life? How can I bring it back to help my communities? That sort of inclusion into the coursework has significant impact for these groups of students in their experience as they go through science. Moreover, importance of experiential learning. So this is the type of learning that is deliberately put in a context, in a real-world context. So you go out, you do something. Maybe you actually teach 8th graders some science, rather than standing in a lecture hall, learning the science, and then writing a report about how maybe 8th graders might be interested in it. You actually go, you interact with the 8th graders, you help them. And understanding the application of knowledge. Not just a bunch of facts, equations, experiments. How do these apply in the real world? What are the limitations? What can I do with them? So you kind of see a little bit of a common thread: clear social purpose, application of knowledge, experiential learning. So tweak number 2, personalize the content. This is somewhat easy to do. So, sometimes some professors, I do this at the beginning of the course, they give a little worksheet that says, tell me what you're interested in, right? What are your interests? So I get all sorts of answers. Some people just say music. Other people say cats, specifically cat videos. So some of those things are a little harder to work with in this context to, make, a calculus tie-in, but it is possible. But it's really looking out for this way to make the content not just, especially in a field like math, not just abstract, something that lives on the board and when you leave the room it's gone, but something that is all around you and that you can discover. So let me talk about the delivery. So there's lots of research. All this research dates back at least 2 or 3 decades, showing that collaborative learning environments help women learn better than competitive ones. So here's a quote from a book aptly called Teaching the Female Brain, How Girls Learn Math and Science. So the quote says, girls prefer to learn as part of a group. The observation has been made that in same-sex groups, in a co-ed science classroom, girls engage in collaborative and cooperative activities combined with lots of conversation about the activity. So this is an interesting idea that can be tested and has been tested in lots of controlled experiments in education. And there's lots of literature on this. And exactly the finding has been confirmed. Collaborative learning environments are better for women's learning than competitive ones. And I'll show you a little bit more data in a minute. So research confirms this, specifically small group and cooperative learning, that it boosts learning for women and students of color. So here's a meta-analysis. It's a little old now, but it's actually a very good meta-analysis of studies dating back to the 1970s. So a meta-analysis is a study of studies. So you go out, before you find the studies, you prescribe some very stringent criteria. I will only include you in my new study if the following are satisfied. And then you take all these studies and you do some really heavy-duty statistics on them, and you try to make some conclusions about the entire group of studies. So that's a meta-analysis. So you're looking for patterns in different studies conducted over time in different groups. So actually, a few of these have been done. This is the one that's cited most often because it's considered to be a very well-done meta-analysis. So here's one of the conclusions. The main effect of small group learning on achievement, persistence, and attitudes among undergraduates in STEM was significant and positive. So that's pretty great. I mean, achievement, we all care about that. How well did you do at the end of the course? Persistence, did you take another math course? Did you persist in the major? Did you graduate with a STEM degree? And attitudes, right? Do you feel like you like your courses? Do you enjoy math? All of that was significant and positive in courses that included small group learning. Moreover, the positive effects were significantly greater. So not just positive, but even more positive for members of underrepresented groups, so African Americans, Latinos. And more favorable attitudes were especially evident in groups of women. So here's the citation down here. So tweak number 3, infuse your course, your program, whatever it is, with small group learning opportunities. Not only will it have positive effects on all the students, in particular, it will have drastically even more positive effects for women and students of color in the group. So quick little summary of our tweaks. So make the content more societally relevant, personalize it, and infuse it with some small group learning opportunities. So there's lots of research, right, that I've alluded to and summarized that leads to these pretty straightforward tweaks. So what we wanted to do here at Wellesley was put some of this into practice. You can imagine it's a little hard to knock on a professor's door and say, hey, change your entire course to do these 3 things. There are debates one can have about academic freedom, and every professor should be allowed their particular way to run their course as they see fit, hopefully informed by the research. And everyone that I've talked to is aware of one or more of these little tweaks and uses some version of this in their course. We in the math department, what we wanted to do was something a little different. We wanted to infuse our courses with all 3 of these little tweaks. So we started this Wellesley Emerging Scholars Initiative. So a little background on this. So this is in 2012. Stanley Chang is another member in the department. We put these findings into practice. We started a program based on similarly successful programs that are based on this research that started in the 60s or in the 70s at UC Berkeley. So our Wellesley Emerging Scholars Initiative, WESI for short, it's a learning community for students of color enrolled in calculus courses. So we meet twice a week for an hour at a time. Students work in small groups on challenging calculus problems. And this is really, the first important subtle thing to point out. So these are underrepresented students. These are students of color. Traditionally, for a variety of reasons, somewhat logical but inherently unfortunate, students of color come in with massive gaps on average in their math background and possibly background in other sciences. And the administration's response, again, somewhat logically, is to say, well, let's put you in a remedial course, right? So let's catch you up first, and then you can go off and take your calculus course. You can imagine, that puts them very far behind. So at some institutions, they don't even get credit for taking, college algebra before calculus. So not only are they behind, they're actually behind on the graduation credits. So all sorts of issues pop up. We at Wellesley don't have a pre-calculus course or a college algebra course. Our lowest math course is Calculus 1. There's an exception. There's a statistics course that's not calculus-based, and that's sort of for the stats area. But a lot of our students do come in with gaps in their pre-calculus background and their algebra background. And again, students of color are more likely to have these gaps. So what this program does is that it turns the logic on its head. And it says, well, they've been admitted to Wellesley. This is a very highly ranked institution. The students that come here are very bright, including the students of color that come here. So let's not assume that they need remediation. Let's assume instead that they have a few gaps. And what we'd like to do is challenge them first. And then in the middle, maybe in step 5 in the problem, if they have some gap that we need to fix, like they don't know how to solve x squared equals 4, at that point we can help them out. So it turns the whole approach up on its head and says, let's give you challenging problems, things that they will be interested in. And in the middle of the problem, if you need some help with something, that's okay. But it's in the service of this larger, more interesting goal. So we got 3-year funding from the program from the Mathematical Association of America in 2013. So that plus 3, that's now. So our funding has lapsed. But luckily, we've gotten some alumni support, some support from the institution. So there's a lot of interest in our program. So some data, so 50% of the participants, these are all underrepresented students, have earned final grades higher than the average final grade of underrepresented students, non-participants in the same course. So this is kind of like apples to apples comparison. If you're a Latina in the program, we compare your final grade to the average of Latinas not in the program in the same class. And 50% of our participants have higher grades. Another 10% have earned grades that are equal to the averages. So I like to say you add that up, so 40% have done worse than the average, right? So at first that's alarming. The thing to remember about these sorts of ways of assessing a program is that the best way to assess the program is if we somehow were able to time travel. So we would take a student at the beginning of the program, see her through all the way to the end, and see how she did, record that data point, then go back in time, and that same student not put her in the program, and then let her just be in the course without our support, and then see how she would have done, and compare those two ending points. Obviously, that's not possible. But every student in the program, and we will tell you that having been in the program helped them tremendously. It's hard to capture that in terms of data because of that impossibility of traveling back in time. This is the next best thing that we can do. Just compare the outcome, without regard for that ability to do that. The other thing to notice is that we are a small college, so we have about 2,400 or so undergraduates. In any given semester, there are maybe 60 to 70 students of color enrolled in calculus courses. So by the time they apply, and by the time we set the schedule and the conflicts get sorted out, we get about 10 to 12 students in our program every semester. So I mentioned this program started at UC Berkeley, a much bigger institution. Other places like UT Austin, University of Michigan, they have much larger sizes of students in these programs. So they are actually more selective. So our application for this program is basically, tell us when you can come to lunch. It's nothing of the form, solve these 9 problems, and if you get 8 of them correct, then you can get in the program, right? So we accept everyone. So with all that information given, right, it still is pretty shocking that 60% of the students do better or equal, in particular 50% do better than their respective average, right? If we were a Berkeley or a UT Austin and we selected based on the best and brightest to be in this program, we would get the phenomenal results, or 80, 90% doing better that this program has been associated with. So, it's a very popular program. So about 50% of all Latinas and 30% of all students of African descent enrolled in calculus courses at all levels, Calculus 1, Calculus 2, Calculus 3, apply to the program. So it's very well known amongst the students, and we do a good job of communicating the program to students of the advisors of students. So we were honored by the White House in fall 2015 as a bright spot in Hispanic education. This was their initiative on educational excellence for Hispanics. So we're doing something right. And now that I've showed you all the research, it's not quite a no-brainer, but it is a little easier to see why structuring a program around small groups, right? Small group learning, focusing on challenging problems as opposed to remedial. You remove the stigma, right? So some of the elements of the research that I have outlined in the beginning of the talk are there, deliberately built into the structure. And one of the greatest things for anybody who cares about these things is that it's a very cheap program, right? So this is how much it costs us to run the program for an entire academic year. So this is good and bad. It's good because it's very cheap, right? Most of the cost is the time and effort that Professor Chang and I put in. So we teach our regular 2 courses every semester, and we meet with these students for 2 hours a week. It ends up being almost a 3rd course when you add the sort of creating the worksheets and meeting with those students. So it's a very cheap program to run. This is bad in the sense that if we try to apply for grant funding, we can run this program for about 3 years and we'll make it to roughly $10,000, right? So, grants, especially for the National Science Foundation, they want you to submit $125,000 or $500,000. Based on these numbers, we would run the program like for eternity. So this is a little hard to get funding. This is one of the reasons why we appreciate alumni support, college support, and really anyone who would support us. The amounts we're talking about are not that large, but the impacts are massive. So, quick recap, we need you. If you're a parent, a teacher, a mentor to young women, someone who knows such a person or is interested in becoming one, tell them about the research in this talk. As a young woman going through career or courses in science, I didn't show the data. This goes all the way back to elementary school. It is, gender bias, gender issues in science and math start very early. So at the very least, if you are aware of some of these things, then you have a context in which you can situate what's going on. You may not think, why do I find myself more interested in biology? And why is it I'm not quite interested in math? A lot of the natural conclusions for young women are, I must not be good at math, right? And they look at the math major, they see a bunch of men, and they say, well, maybe that's not the place for me. Maybe they are better at math than I am. The research shows that the story is much more complicated, right? In general, that's not true to begin with. But the research shows that it goes back to the content's context, the content's delivery, just because of the way the courses are usually structured, it's not quite the best learning environment for women. So if they know that, that changes the ballgame entirely. So you can download this talk down here. This is a different font, but this is a 1 and that's an I. So if you type it in that way, it'll work. And thank you so much. I'll take any questions. Yes.
In the mathematics department,
Yeah.
in addition to this and above and beyond this program, the Emerging Scholars Initiative,
Yeah.
you have what, 20, 30 majors a year?
That's right. We have between 20 and 30 a year.
So is the Wellesley Mathematics Department aware of how to apply mathematics to the kinds of things that women are interested in as they teach their program? Or do you feel very much alone
Yeah.
in the department?
Well, I'll say first of all that the math department totally supports what we do. And I'll say second that actually the number of math majors that we've been having have been increasing. The number of math majors we've been having have been increasing over time. So we have about 14 faculty in the department, and everyone has a different teaching style. But as I mentioned earlier, all the faculty in the math department are aware of one or more of these research-based ways to boost success in math for women specifically. A lot of our math faculty have gotten Pinansky Teaching Awards. So that's awarded for excellent teaching for one of the faculty in our about 300 or so faculty. So the research that I presented is very targeted and makes very specific recommendations about tweaks to courses. It doesn't imply that you should overhaul the entire course to be, for example, completely project-based or to be completely personalized. It just suggests that you infuse the course with some of these elements. So our faculty do that in a variety of ways, in a variety of levels in the math department, which is, I think, one of the reasons why our majors numbers have been going up, one of the reasons why we graduate so many math majors. I think 6 or 7% of Wellesley undergraduates graduate with a degree in math. I think economics is the most popular major, and economics and math, I believe, is the most popular double major. So in short, the math department as a whole already uses many of these tweaks. The point is not to constrain a faculty member or every faculty member to run their classes in a certain way, to allow instead for some diversity in teaching, right, that may provide other tweaks that either research hasn't discovered or that research has discovered that I haven't talked about, right? There's a lot of other stuff out there. So we definitely do not feel alone in our program and in our approach. Great question. Yes?
Are there efforts afoot to integrate math, computer science, statistics across the curriculum on campus? I'm thinking in particular of sort of data science programs that other colleges and universities are starting to offer.
Yeah.
Because that seems to me a perfect opportunity to take these sort of technical areas and let people find applications they're really interested in.
Yeah.
And maybe double majors or even concentrations or something like that.
Yeah.
Something like that going on here at Wellesley?
Yes. Now it is. So I'm an applied mathematician by training. One of the reasons that I was hired in 2011 was because the college recognized that they wanted more applications-oriented content, specifically in the math department, but also more broadly in science. You can imagine at a liberal arts institution, the focus is not engineering, things that are very hands-on. So there is always a little bit of a struggle between the philosophy of a liberal arts education and something that is like a data science major, which is very applied. You expect those sorts of things to be institutionally prioritized at a place like MIT or Caltech, at an institute of technology or similar places that are very real-world application engineering focused. But the college is realizing and has made lots of strides in that direction. So we in the math department, for example, just hired our first statistician. And we have another statistician who has been working at the college. She heads our Quantitative Analysis Institute. So she's been teaching courses also. So we are slowly building a statistics program partly in recognition of other liberal arts colleges like Amherst, like Smith, who have data science programs or statistics majors, and its popularity. Students really do want that. They want that application. And with a group of women students, there's no surprise as to one of the reasons why that might be true. So we're making a lot of strides on that front.
Is there a question over here?
So in terms of the remediation that you've been able to find for these students, are there any certain things that seem to have worked better? You talked about creating worksheets and everything, and I know there's a lot of videos out there and different things.
Yeah.
So in our experience, remediation is tricky. You don't even want to mention the word remediation. You also, even the title of a program, you want to structure very carefully. You don't want to avoid the student being associated with the program and creating a stigma. So if we called our program the Wellesley Remediation Scholars Initiative, right, that would be bad. The actual process of filling any gaps, we have found through the literature on this program, if you focus it on these challenging problems, these interesting problems, that's really the way to go. So in step 5, you can't do the problem, then we come in and it's effectively remediation at that point, but that's not the goal of solving the problem at that point. So that seems to be particularly effective, and that's been shown back to the history of this particular program. Yeah.
So how did school introduce the industry best practices in terms of like there's a very popular Six Sigma application linked to the economic educations and linked to the business strategy in the sense of high level in terms of philosophy. Basically, it's about the fundamental application introduction linked to the applied mathematics and statistics.
So is the question about how to balance maybe the theoretical and the applied?
Yeah, and also introduce the industry best practices in terms of how to apply the statistics.
Sure.
Using Six Sigma, for example, by no means that's kind of
Sure.
well practiced in the academic world, but much more practical from the engineering, from the economics, and EA and the MBA, for example.
Yeah. No, that's a great question. So it goes back to this issue of a little bit of the tension between allowing faculty to have the freedom to run their courses and at the same time informing faculty about some of the best practices in the field and some of the current interests. Just like the Martin Luther King Jr. quote, there's sort of a long arc to academia. So 20, 30 years ago, small group learning research was just starting to emerge, and some of these studies showing its effectiveness were just starting to come out. Fast forward to now, it's very clear that this is the way to go. But in those intervening 20 or 30 years, right, there are very few adopters. There were early adopters, as with anything else. So even things like this, you can see the landscape changing. So as I mentioned here at Wellesley, it's becoming a bit more focused on real-world applications. We hired a statistician. We launched a new career initiative, college to career initiative recently. So, these things in general take time. Specifically in the economics department, our economics major is a bit more on the theoretical side. But more and more faculty are coming in with experience in management and business, so they are infusing slowly their courses with that. But it takes a while for those junior faculty, if they make tenure, to stay here and become department chairs and influence the curriculum. So that's the long arc of this. But students are demanding it. So our numbers for econ majors, for science majors, are just increasing. So there's clear interest on the part of students, and that also drives course and pedagogy. Yeah.
Yes.
I would say that do you guys push back on publishers? Because it seems like a lot of the materials that faculty are using are driven by the publisher. Do they provide the kind of context that you're looking for, or is that still something that they haven't caught up to you yet?
Well, I think it depends on the field. I can only speak for math. I'm not too familiar with the diversity of approaches in economics textbooks, for example. In math, partly because of all this research, so there are a lot of people like Freeman Jabrowski, who is the president of University of Maryland College, Baltimore, who's a mathematician. And he's been very integral. He created what's called the Meyerhoff Scholars Program, which is nationally recognized as one of the best programs to get students of color interested in STEM fields. The person that I mentioned our program is based off of, his name is Yuri Treisman. He was a mathematician at UC Berkeley. And there's a long history in mathematics of using project-based learning going back to R.L. Moore, a topologist in the 40s. So math in particular has been a leader, if you will, in this field of applying some of these techniques that just happen to work well for all students, and in particular women and students of color. And I think partly for that reason, a lot of textbooks have grown up around these issues. So there are inquiry-based learning textbooks in number theory, for example. You know, I haven't done a search again, but I'd be surprised if there are inquiry-based learning textbooks on macroeconomics or something. I don't know. So I think it's part of the history of math being so involved in these approaches for such a long time that publishers in that area have recognized it. But my sense is that, you know, in other areas it's starting to become more and more important for other people, publishers, to publish things like this. Is there another question over there? Yeah.
Yeah, I guess this is more of a comment, but and I think you touched upon it with the career initiative you're doing. But I do think a lot of the students, current students now, are more attuned to career opportunities in STEM fields, and I think they automatically, it's a fact that a lot of the STEM fields are very male-dominated, and so I think they have a little bit of awareness to entering those fields from a career basis and kind of shy away from that. So I think your career initiative may slowly change that, but it's kind of a vicious cycle too, because as less enter, then, and you said the rate of entrance for men are greater, so it's a little bit of a tricky issue, because in order to educate women that there are these, open up the door to great opportunities in STEM careers, whereas it's so male dominated, they're like, maybe, you know, I should go into social sciences or something. So I don't know how to quite address it, but just it's more of a comment than a...
Yes, no, I mean, that's exactly what's going on. You know, it's pressure from at least those two sides. You know, the courses in psychology, biosciences, they're structured, as I said, intrinsically or discernible societal relevance. You have the research showing that instantly appeals more to women in general. And then they go out to the workforce, they just, you know, walk into a company and they see the challenge of being a woman in computer science, for example, and just the numbers are just not there. So you have at least those two big forces challenging women. So we are conscious of that, and that's sort of the College to Career initiative. The internship experience at Wellesley is also really important aspect of students. So many of our students, especially the math and econ double majors, do internships in the summer. So they end up going places to like the Federal Reserve banks, or they end up doing some internship at a consulting company. Those often tend to be male-dominated fields, but what's great about it is that they do the internship while they're here. So they have sort of the support structure, if you will, of the college while they are getting their internship experience. So that's sort of one way to mitigate this factor, rather than just having them, you know, dropping them off. Okay, you got your bachelor's, go out and by yourself, figure it out. Having an internship experience, having multiple internship experiences where you come back to Wellesley, right, and you have that backdrop is really effective, is what we are seeing. So, yes.
This is also a comment, and I'm a mom of a junior. I wasn't aware of this program. I think part of it, if you need to recruit more students instead of just offering them lunch to come to this program, is to build the awareness.
Yeah.
And I was thinking about it, maybe when the students are admitted to Wellesley, sending from the math department, sending an email to the parents and to the college counselors of the schools, the guidance counselor, hey, there's something, you might benefit from it, go seek it out. I think that might help students become aware of this.
Yes, I totally agree. And, you know, we started doing this a few months ago, actually. So we contact students. You know, so the tricky part is identification. So you don't want to spam everybody. You want to somehow capture students that are thinking of taking a course, and specifically a calculus course, in their first semester here, or maybe interested in science. That's problem number one. Like, not every student indicates that interest. Not every student knows. So identification is an issue. But there are lots of students that do indicate an interest in science. And we started, you know, a few months ago to email them before they got here. I've been involved with programs at other places that are somewhat similar to this. And they do send handwritten letters to parents. And I do remember from those programs that that was very effective. So I think, your suggestions are exactly on point. Other questions? Okay, great. So feel free to download the talk. I'll hang around for a few minutes if you have any other questions. And thanks for coming.